that being said, let's get into a logical operators game. So I'd like for everyone to either click into this game or just follow along in the front of the screen. This is bringing us into our unit 2 and 3 slides. All right. Just like last class, we'll play this game. I'll be asking for some volunteers. And then after we play the game, for anyone who volunteered who hasn't yet received a sticker, I'll ask for you to raise your hand. I'll distribute some stickers, and then we'll move on. Last class, we talked about some different operators and we practiced using them, but let's recap. So the way this game goes is that in the left column, you see a number of expressions. If we were to evaluate these expressions in Python, what would we see as the result? That's the game that we're playing. In other words, if we were to stick this expression inside a print statement, what would we see come out? So I love a volunteer for A, true or false. Yeah, true. Why? Exactly. So I'm just gonna get out my annotation tools here. So the first one is true, but why? Here, the operator in question is the OR operator. When we're dealing with the OR operator, if either side is true, then the resulting expression is true. So it is literally the case that we have literally true on the left, and so we're done. The resulting expression is true. The key there is we're using the OR operator. All right, thanks. So next up is B. True or, true and false. Yeah.
This would be false.
False, why?
You can't have a statement.
Yes. So here the operator in question is the AND operator. With the AND operator, both sides need to be true in order for the resulting expression to be true. That's not the case here. This is false. Cool, let's keep it moving. So C, 2 + 2 = 4. What's that about? For it. True, why? Yeah, this one is true. Heads up, all these are either true or false, by the way. So if you need to guess, 50% chance of getting it right. Here, the $= is our operator. And it asks, is what's on the left equal to what's on the right? Question mark. And so it is the case that 2 + 2 is 4, and that's the same as 4. So these are equal, so this is true. All right. Yeah, question, or you want to do the next one? Next one, sure. What's right? Right, exactly. Nice. Cool. So exclamation point =, is the opposite. It's like, is what's on the left not equal to what's on the right? And since these are equal, that this is false. All right, next up, E. Yeah.
I'd say false, because even though it's 500 and 500, the computer
Yes. Operator here is the $=. We're like, is what's on the left equal to what's on the right? And although these look similar, we talked about data types last class and how the string version of a number is like not the same as the actual numeric version of that number. We can't do math with this 500 in quotes, for example, but we could do math with this literal 500 integer. Anyway, if the data types aren't matching, these really aren't the same objects. So it's not the case that these are equal. So this is false, I think. All right, cool. Let's keep it moving. Yeah, here we're dealing with the IN operator. We might not have talked about this explicitly, but you'll see it in the material that I shared about logical operators. The IN operator is testing inclusion. And it says, or it's asking, is what's on the left included in what's on the right? And so we have a few types of objects that we could use to do this inclusion checking. The one that we see here on the right is what kind of data type. We talked about it very briefly, and we'll get back into these a lot more next week. But 1, 2, 5 with these square brackets, what is that about? What kind of object is that? What data type is that? Yeah. It's a list, exactly. We'll deal with lists in so much more detail next week. Basically, the list is denoted by these square brackets and comma separated items. And so inclusion here, the number 5 is included in this list, 1, 2, and 5. So this is true. All right, G. Volunteer?
It's true because hello is in the phrase hello.
Yes, we're doing some substring checking here, still using the in operator, testing inclusion. Sure, we could do inclusion. Is this item in our list of items? Like in F? But we can also do it with a string, like is this substring in this greater string? And this is case sensitive. And so because we do see the word hello with a capital H included in this larger string on the right, this is true. Nice. Yeah, not in is like the opposite of the in operator. And so because we do have a capital H included in this greater string on the right, this is false. It's not the case that H is not in that string. All right, cool. 2 more. Getting into some compound expressions here. You may have started to do these compound expressions with your exercise, and you will get into these with your rock, paper, scissors. Yeah.
It's true,
True, why?
because,
Yeah, here we're dealing with the and operator. Order of operations matters here. We use parentheses sometimes to denote order of operations, just like your algebra days. And so we're asking essentially here, once we evaluate the right-hand side of this expression, 2 + 2, that is equal to 4. So this evaluates to true on the right. And now what we're asked is true and true. Are they both true? Yeah. So result is true. Awesome. Thank you. Last one. Can you say that again? Yeah, exactly. Here, the main operator that we're dealing with is the or operator. So only one side needs to be true for this resulting expression to be true. So let's start on the left. Is 5 included in this list? Yeah, we already saw this before. It was true. And so we're done. One side is true. So the resulting expression is true. Awesome. High five to all those volunteers. Thanks. And I'll take a screenshot and share the results after class.